just checking if I've got the wires wired up right. Hang on a minute. Right. Okay. Remember the racing car motor? This great big thing that's in there. I took all the wire off the motor, because it was this heavy duty thick 0.74 millimeter thick wire. Now obviously it was more current based than voltage, because it was just ridiculous. It was designed to run at some ridiculous voltage like 3 volts, which was no good for what I'm doing, because my general voltages I'm using are really 12 volts. Also, it used to burn up my leads. When I was using my thin leads, the ones from China, they used to get hot, right? They used to get all my power was lost in the heat from the wires. So I decided the other day to rewind the motor. So I basically took off about 30 turns, something like 20-30 turns of wire off the motor commutator. Oh, let me see if I can get the torch in there. Don't know if you'll be able to see it, but I rewound that. Hang on, see if I can get the light in. Ah, it's not easy to see now, it's in there. There you go. You can see my wires that I rewound, part of them. So the commutator was completely rewound with each segment 230 turns. The commutator's down at the bottom somewhere. If we can get the light on it. It's hard to see it now. Right, just about. Right, you can just about make it out down there. So I cleaned it all up, rewound it, and now I've got loads and loads of torque. But the pulley system I've got here, I'm using 3 motors actually. I'm using the smaller motors. I'm using these smaller motors to drive the centrifugal fan assembly, and I've also got this high torque motor. So basically I'll start this up, and this was in the hope that I could get the enough air flowing through the centrifugal fan assembly to drive my turbine. Well, yeah, it's like, well, this was all experimental to see if it would work, and I'm not moving enough air to get the turbines to actually start running. So what I'm going to have to do at some point is to actually make the turbines smaller. You can see how big this thing's got. It's I'm leaning back in my chair now. Yeah, it's big. But the turbine section at the bottom, I can feel the drive shaft when I stick my finger down there. The air comes out the bottom here when it's running, and it's not turning. What I'll do is I'll stick the phone on its back and point it so it's pointing directly upwards to see if the turbine's moving. I'll try and start it with my finger to see if I can get it to go when I start this thing going, but there's not enough airflow. So what I'm going to have to do at some point, I think really what I need to do is to make these turbines, scale them down. You know, this is going to be another day though, because I'm printing the parts for the bubbleator cylindrical stuff right now. I'm doing a different project. Right, I'm going to start on that because I've been at this for so long, and I am kind of disappointed really that I didn't get enough airflow. But it does actually spin. The turbines do spin when I hook the vacuum cleaner up to it. You know, when I stick the vacuum cleaner on, there's a lot more airflow, and obviously it does work then, but it's, yeah, that's not the point. The whole point is this is supposed to work off the small centrifugal fan assembly that I've got on top, which is not quite getting the airflow. So now if I scaled all these turbines down, and so the air was in a smaller, tighter formation, then they would work probably, because you see I haven't got enough air coming through to turn them all. That's the problem. The air flow is just not high enough without actually putting more juice in here, which is why I've rewound this big motor, which has got a lot of torque, to see if I could actually get to the point of unity, which is basically equal sort of thing, where it can actually turn the turbines. I'm not even near unity, which is the point where you actually get rotation. So I'm not there. I'm not even at unity point. I mean, I'm not talking about over unity. I'm talking about unity, where you have power energy coming in, and you harvest that energy to do some work. Well, it's not even at that point. So I thought I'd do an update. Right, I've got my meter on amps. Right, that's on 10 amp range. Because this big motor up here takes about, well, it's stalled. When it's stalled, it's about 2-3 amps, and then once it gets speed up, it drops down to about 700 milliamps, especially when these little motors are all running. So the current drops right down. So what I'm going to do is, first thing I'm going to do is start the little motors up, and I've got to connect this clip here, and it will start to move very slowly. And that's current limited at 700. It's current limited. You can see over there on my meter, right? Well, that's how much current these these two motors are using to turn it. So I've got some initial turn at the moment. Now I'm going to connect my turbo motor. Right, so I've got to connect this turbo to this battery clip, and there's nothing on the meter right now. Now listen to this. I'll get this hooked up. Oops, I need to bring this terminal up more. There we go. Now this is giving a lot more torque now, and the current is at 700 milliamps, and it's blowing out at the bottom here. Question is it driving the turbine? So here we go. I'm going to put the phone on its back. Oh, this is heavy. Oh, I'm lifting my batteries up. I need the torch. Where's my torch? Is it driving it? No, it's not. It's only just barely able to move. Right, so it's not able to turn it. Right? But we have got air coming through all the system. Just to show you what I mean, let's get this bit of sandpaper. We'll stick it near the bottom where the air's coming out. Down here. Oh, it doesn't really show up, does it? But there is air flowing down there. It's coming out the bottom. So air is going all the way through the system. I just haven't got to the unity point. So this is how much power the big motor's using, and the batteries appear to be cool, the cold, but I think the voltage is dropping on the batteries because they're driving the big motor at the top, which has got a lot more torque, and it's cool. It's not overheating or anything. Let's check some temperatures on the motor. Yeah, the motor's nice and cool, 30 Celsius. Let's see if we can point it through that hole. Yeah, the motor's not burning up, which is great because it used to burn up with the 12 volts, and the battery seems to be going down. Battery voltage is slowly dropping. Yeah, so yes, there's the airflow. Basically, I need to improve these. I need to either swap these centrifugal fans out, put a different set in. I've got all these other sets scattered around the room which I can put in and try different ones or add more, but the more I add, the more drag I get on the system. That's the problem, because they do increase more drag. So just thought I'd give you an update on where we are at the moment. The high torque motor is working very well. That's our pulley system, using elastic bands. So yes, I thought you'd be interested in see where we are at the moment with this project. So it's a project for a rainy day, because it's purely experimental. It's purely for me to explore about air, because it's something I'm not really skilled with. I mean, in the past I've really done a lot of work with fans and turbines and things, so it's, yeah, I'm a bit disappointed I'm not getting my turbines to go, but I have a suspicion that one of the bearings has got snagged up a bit as well. I think one of the bearings on the turbine at the bottom I might have got some glue in it by mistake, so I'm going to have to dismantle the turbines and check them out again, which is a pain in the neck. So anyway, there we are at the moment. The batteries are cold, they're not getting warm, and we're only well, the current's dropping, look. We're down to 600 milliamps. That's because the battery voltage is dropping slowly. So I just thought that you know where we are with that. The motor, let's check again. I'm touching the actual commutator drive shaft at the bottom, which is where most of the heat will be. And it's cool. It's not burning up, because obviously all these three motors are working together, they're all helping each other, and on the actual current on the meter across there, which is driving the other two, it's about 350 milliamps. So these two motors here are using 350 milliamps between them, so they're assisting in the torque. Anyway, that's where we are with that. But I want to get on with the cylindrical bubbleator project, you know, which is what I'm printing right now. I've actually printed a few parts already. Let's have a look. Here's some of the parts I've printed, which are for the coil holders, the Lego style system where these clip together basically. So these are actually, get the right way up, they clip together like that in a long array. And yeah, we've got a few of these parts done, but we need a lot more done. Yeah. Now this tube is just waste material. All the different skirt walls of the prints I did, I stuck them all together to make a little thing where things can dry out slowly without drafts, so they don't shrink. So anyway, that's where we are with that at the moment. Not much else to show you, I'm afraid. But we haven't got enough air to turn the turbine yet, so I'm disappointed, but I did expect that there would be some disappointments. So I'll turn this off now. And it's just running on the two little motors now. Disconnect those. Yeah, okay, well, we'll come back to that at some point in the future, because what I'm thinking about doing, as I say, is scaling the turbine section down so the air is more compact, and having a miniature turbine system instead of the great big one, because what I'm trying to do basically is push a small amount of air over a large area, which is the problem. So I need to basically make some miniature versions which are 1/3 the scale or possibly less, but I don't want to go too small because the drive shaft itself is going to be the same one. It's going to be 6mm drive shaft, so I can't go too small. But if I can go down to 1/3 the scale for the turbine section and have an adapter between my air that's coming in, I should get movement then. So, well, almost certainly will get movement. It's just the amount of air that's coming through here is just over too large an area, and it's just not able to reach unity. Yeah. Okay, that's it for now.